Hello and welcome back to this channel. Dear students, this is the quick revision for the subject radiation and microwave theory. So, first part is fundamental equation for free space propagation. ये एक important derivation है जो मैंने regular video में already cover किया है. So, I have written the direct formula. The formula is also known as free space equation. So this is the basic equation. इसका derivation है जो आप लोगों को करना है, which we have already covered in the earlier video. So the formula is P received upon P radiated. REC stands for received, RED stands for radiated. So it is GD max base T. These two base T and R are related to transmitting antenna and receiving antenna. GD max means maximum. GD is directive gain or directivity. So GD max T is directivity of transmitting antenna. GD max R is directivity of receiving antenna. Lambda is operating wavelength, which is given as C upon F. F is the operating frequency. C is the speed of light, and we know that C is 3 into 10 raised to 8 meters per second. R, small r, is the distance between transmitting and receiving antenna. So this is an important formula. इस formula में ये जो term है lambda upon 4 pi r bracket square, इसका अगर reciprocal ले लेंगे हम लोग, मतलब if it is 4 pi r upon lambda bracket square, then this term is called path loss. So this is the basic equation of path loss. अगर dB में calculate करना है तो 10 log of this term will be the corresponding path loss in dB. Now let us talk about the radiation mechanism of an antenna. We know that antenna is a device which is used at transmitting end or receiving end. So it is the device which is basically responsible for transmitting electromagnetic waves from one end to the another end. At another end, that means at receiving end, this device is basically used to capture electromagnetic waves. So this is the antenna. Do remember certain basic things. If the electron which is flowing through the wire is stationary or moving with constant velocity, then there will not be any radiation. But if electron is which are moving through the wire produces certain acceleration, or there is certain acceleration or deceleration, then radiation is possible. So these are the diagrams which shows how a single wire, how to generate a radiation from a single wire. So if it is a curved wire, then at this end, at this bend where the curved portion is there, radiation is possible. So I have shown radiation from both the ends. Second diagram, if the wire is bent, this portion indicates wire is bent like this. So if electrons are moving through this wire and certain bend is there, then again there will be change in the velocity and radiation is possible. Next is truncated wire. Truncated means this is the open end, the another end is suddenly turned, suddenly closed. This is the truncation, because of which there will be change in the speed of waves, speed of electrons which are flowing through this wire. So radiation is possible. Then discontinuous wire. Up to this distance, there is a particular diameter. After that, diameter of a wire through which electrons are moving is increased. Due to sudden change in the structure, dimensions of the structure, radiation is possible from these two ends. The last type of radiation which we are generating due to a single wire is, suppose this is the wire and after certain distance, certain load impedance is connected, then again there will be sudden change or deceleration or acceleration, and because of which radiation is possible. So this is about how the radiation is created or formed due to a single wire. Now we will discuss how the radiation is generated from the two wires. We are considering a short dipole antenna which is center fed. This is the signal which we are applying to feed this type of antenna. That means let us make it simple. ये जो सिग्नल है ये एंटीना के सेंटर में फीड किया है, अप्लाई किया है. So this type of antenna is a short dipole antenna. Observe this time period. The total time period of this waveform consists of positive half cycle and negative half cycle. Total time period is T. 0 to T by 2 we have positive half cycle, T by 2 to T we have negative half cycle. Again if you divide positive half cycle into two parts, तो यहाँ से यहाँ तक मतलब 0 to T by 4 we are getting increasing positive half cycle, T by 4 to T by 2 we are getting decaying positive half cycle. Now this kind of waveform is applied or fed at the center of this antenna, short dipole antenna. So during this portion 0 to t by 4, when the charges are increasing, we'll consider that three lines of force are generated, and these lines of force are in downward direction. Again, this number 3 is assumption, as well as the direction is assumption. We are considering the upper portion is positive, lower is negative. So make the thing simple. During the period 0 to t by 4, three downward lines of force are generated. These lines of force travel a distance lambda by 4. Now, during the next quarter period, that means from t by 4 to t by 2, the value is decreasing, charges are decreasing, because of which three more lines are generated, which are shown by these three upward arrows. So these are the three more lines which are generated during the time period t by 4 to t by 2. These lines of force will be in opposite direction, because in this case the charges are decreasing. In the earlier case, from 0 to t by 4, the value was increasing. So these three lines are generated and it will be in opposite direction. That means it will be in downward direction. So at the end of t by 2 time period, total 6 lines of force will be there, because earlier there were 3 lines of force. So during the time interval t by 4 to t by 2, these 3 originally generated lines of force will travel an additional distance of lambda by 4. तो ये lambda by 4 और ये lambda by 4, तो ये original जो generate हो गए थे 3 lines of force, these lines of force will appear over here, and these 3 new lines of force are generated, which are in upward direction. Now at the end of this time period t by 4, there is no force which will keep these lines of force attached to the structure. So the force becomes 0, because of which these 6 number of lines of force will be detached, will be separated out from the structure, and this kind of pattern is generated, which is called the radiation pattern. Next part is types of antenna. From the exam point of view, you may expect the question like this: define the term antenna and explain its different type, or list out the different types of antenna and explain any two types of antenna. So this chart shows different types of antennas. First is single wire antenna. I have written only wire, it is basically single wire antenna. सेकंड अपर्चर एंटीना. अब देखो पहला जो सिंगल वायर एंटीना है उसमें सब कैटेगरीज है. फर्स्ट इज लीनियर वायर एंटीना, देन लूप एंटीना एंड हेलिकल एंटीना. As the name indicates, these antennas are designed by making use of a single wire. So if you bend the single wire or if you truncate the single wire, then radiation is possible. Now this is the diagram of linear wire antenna, which is also called a dipole. Next is loop antenna, second subcategory. So the commonly used loops are square loop and circular loop. Again, third type is helical antenna. If you form the wire in terms of helix, then this structure acts as helical antenna. So this is the subtypes of single wire antenna. Next is aperture antenna. Aperture antenna are basically related to waveguides. So it can be rectangular waveguide or circular waveguide and so on. Then most popular antenna is microstrip antenna. Certain patches created and accordingly the radiation is generated. Next is the reflector antenna. As the name indicates, it is providing the radiation, it is generating the radiation on the principle of reflection. Then in many applications, single antenna is not sufficient. In that case, number of antennas are stacked together, connected together. This is called antenna array. Yagi-Uda antenna array is common example of antenna array. And last type of antenna is lens antenna. Like the working principle of lens, this type of antenna works. So this is the different types of, this chart shows the different types of antennas. इससे related already मैंने detailed video बनाया है. So I have just given the overview of these types of antenna. The next part is antenna parameters. From the exam point of view, you may expect the question like this: define and explain the following parameters of antenna. So first is radiation pattern. It is also called field distribution pattern. You need to remember this diagram. It's very simple diagram. What is a radiation pattern? If I'm talking about a transmitting antenna, then transmitting antenna radiates or transmits the signal. So if you draw the diagram which shows distribution of energy in the free space, that is called radiation pattern. there is one particular lobe or there is one particular direction along which you are getting a maximum output, that is called major lobe. So this part which is drawn with this red ink is the major lobe. So this is the diagram of major lobe. As I said, along this axis you are getting a maximum output. Apart from this major lobe, there are certain other directions where you are getting minimum radiation. These are called side lobes. But side lobes are in the same hemisphere as that of the major lobe. From the back side of antenna, you are getting some radiation that is called back lobes. So back lobes are in opposite hemisphere compared to the major lobe. So again, I have shown two more notations, E field pattern and H field pattern. E is electric field, H is magnetic field. So radiation pattern which contains electric field intensity is E field pattern. Radiation pattern which contains magnetic field intensity is H field pattern. So these are the few terms related to radiation pattern. Next parameter is efficiency of antenna. So it is basically ratio of radiated power, PR means radiated power, upon total power. Total power is the power supplied to antenna. This total power can be also written as PR plus PL. As I said, PR is radiated power, PL is the loss power. In terms of resistance, the same equation can be written as RR upon RR plus RL, where R to the base small r is radiation resistance, RL is the loss resistance. Next is beam width. Again, refer the same diagram. This is the major lobe. Let us say at this point you are getting a maximum radiation. So A and B are the 2 points at which you are getting 50% radiation, one half of the radiation compared to the maximum point. So you can well say like this, A and B are the 2 points at which the power is 3 dB down compared to the maximum power. So if you measure the angular width between these 2 points, it is called half power beam width, because it is the angular width, so it is a beam width, and at these points A and B you are getting half of the power, so it is half power beam width. Next is bandwidth. It is range of frequencies. One more thing, I have shown in this diagram BWFN. These dotted lines indicates the directions at which you are getting a zero output, that is null output. So angular width between these 2 points is beam width between first nulls. So these are the null positions. Next is the bandwidth. It is range of frequencies over which a particular antenna operates. Then radiation intensity, it is denoted by U and defined as power per unit solid angle. P bar is power and D ohm is solid angle. Next parameter is gain of antenna. It is basically a relative term. We are using two antennas. One is reference antenna. Reference antenna means isotropic antenna, and isotropic antenna is an antenna which radiates equally in all possible directions. There is one more term which is टेस्ट एंटीना. टेस्ट एंटीना मतलब जो एंटीना जिसका हम लोगों को अगेन मेजर करना है, that is called टेस्ट एंटीना. So U means radiation intensity. So gain of antenna is ratio of radiation intensity of test antenna to the radiation intensity of reference antenna. As I said, reference antenna is isotropic antenna. So it is also expressed as U max upon U0. U0 is the radiation intensity of isotropic antenna. Next is directive gain. There is a particular extent at which a practical antenna radiates compared to the reference antenna. So the extent to which practical antenna concentrates its radiated energy related to the isotropic antenna is called directive gain. Formula is GD is equals to PD, power dissipated upon average power, P average. Next is effective length. So basically effective length gives us an idea how effectively the given antenna radiates or receives EM, that is electromagnetic waves, and formula is, notation is LE, effective length. Formula is voltage upon electric field intensity. Next is impedance of an antenna. Basically it represents input impedance, and we have to measure this input impedance at a point where a transmission line is connected to an antenna. The last parameter is radiation density. It is the power density associated with EM, that is electromagnetic frequency EMF, of an antenna in the far field region. So these are the terms related to the antenna parameters. Now let us discuss how to attempt the numericals as far as this antenna parameters are concerned, I have made a list of formulae. These formulae are sufficient to attempt any numerical. First formula is formula of efficiency. Efficiency is denoted by eta, which is RR, radiation resistance, divided by RR, again radiation resistance, plus RL. RL is the loss resistance. Another formula is PR, radiated power, upon Pin. Pin is the input power. Then directivity is denoted by D, which is GP. GP is the power gain upon efficiency. One more formula is U max. U is radiation intensity, so max stands for maximum radiation intensity upon PR. PR is radiated power divided by 4 pi. Directivity is also called directive gain, which is denoted by ZD. It is PD upon P average. PD is dissipated power, P average is average power. Dissipated power is given by 1/2 E0 square. E0 is electric field intensity upon eta 0. This value of eta 0 is called, this term eta 0 is intrinsic impedance of free space, and this is a standard value which is 377 ohm, divided by PR. PR is radiated power upon 4 pi r square. This r is the distance of the point from an antenna. Then radiated power PR is surface integration of U is radiation intensity, into d ohm. D ohm is solid angle. This is also called d omega, which is again given as U into sine theta d phi. Then solid angle omega is 4 pi upon d. D is the directivity, and half power beam width is ohm upon 2. Now let us solve one numerical. Calculate the directivity for radiation pattern U theta comma phi. This theta comma phi indicates U radiation intensity is a function of theta and phi coordinates, which is given as U0 sine theta sine square phi, where theta is less than 0 comma phi less than or equals to pi. It means that both the values theta and phi varies from 0 to pi. We have to calculate the directivity. Now look at the available formulae. So we have this is the list of formulae. Out of this, I will be making use of this formula which contains U, that is radiation intensity. So U max, that is maximum radiation intensity, upon PR upon 4 pi. This is the given value of U. How to calculate U max? See, given value of U is U0 sine theta sine square phi. U0 is constant value. Maximum value depends on the values of theta and phi, and we know that sine square or sine value maximum is 1. So it is this value 1 into U0. So U max is equals to U0. Whatever term it may be getting multiplied with U0, suppose it is cost term, जो भी value है उसका value 1 लेना है. A simple trick याद रख लो, and remaining term is U0. So I am writing U max is equals to U0. Now look at the formula. I have to calculate directivity. U max I have just now explained, divided by PR upon 4 pi. Now I need to calculate value of PR by making use of formula number 3. So PR is equals to surface integration of U into d ohm, where d omega or d ohm, where value of d ohm is given as sine theta d phi into U. That means I have to put this value of U. U is given as U0 sine theta sine square phi into, see, this is the value of U, into sine theta d phi. So into sine theta d phi, and variation of theta and phi is given as 0 to pi. So U0 is constant. I will write it like this. This sine term, sine theta into sine theta, becomes sine square theta. Limits are theta is equals to 0 to pi, and second term sine square phi, limits are again 0 to pi. This is d theta, where this variable is d phi. You can well solve this such calculations using the calculator. So it becomes U0 inside the bracket 2.4649. This is the value of PR, that is radiated power. Now we need to calculate the directivity. Look at the formula U0 upon PR upon 4 pi. So this is the value of PR. Therefore, directivity D is equals to U max. U max is U0 upon PR. Value of PR is this value U0 into 2.4649 divided by 4 pi. u0 gets cancelled. Therefore, value of D will be 5.0981. 0981. This value is in normal unit, so we need to convert it in terms of dB. How to convert it? It is 10 log of this calculated value. So D in dB, that is directivity in dB, is 10 log of this value, which is 7.074 dB. So this is the answer of directivity. As I said, you just have to remember this list of formula. You will be in a position to attempt the numerical related to this part. The last part of this unit is antenna polarization. From the exam point of view, you may expect the short note related to this polarization. So, definition is the time varying behavior of electric field strength. We know that electric field strength means E bar. So, time varying behavior of E bar in the space, in the free space, is called antenna polarization. Now, if E bar is along X direction, then it is said that if E bar is say along X direction, that means direction is X bar. It is said that the wave is polarized along X. Similarly, if E bar is along Y, it is said that the wave is polarized along Y direction, and so on. There are three major types of antenna polarization. One is linear polarization, second is elliptical polarization, third is circular polarization. So, this is the theoretical point. Please do watch the related video of antenna polarization. So, dear students, that's it for this quick revision session of antenna and radiation. So, thank you. Thanks a lot for watching this video.